हेलो एवरीवन, वेलकम टू गेटवे। इस वीडियो को शुरू करने से पहले मैं ये बताना चाहूँगा कि इस वीडियो का हिंदी वर्जन जो है आपको हिंदी प्लेलिस्ट में मिल जाएगा। तो अगर आप देखना चाहते हैं तो आप उस वीडियो को वहाँ से देख सकते हैं। Now we will continue to the video. Start the video. The video is related to the Bioprocess Engineering and Bioprocess Technology PYQs of GATE 2022. Right? Let's move to the first question. A bacterial strain is grown in nutrient media at 37.37 degrees Celsius under aerobic conditions. The medium is inoculated with 10 to the power 2 given cells from a seed culture. So the question is saying, we will see what is given in the question. Okay. So the question is saying the initial count of cells is 10 to the power 2, which is indicated as N naught. Initial number of cells, it is given 10 to the power 2. Okay. If the number of cells in the culture is 10 to the power 5 after 10 hours of growth, the doubling time of the strain is, the next thing is given is after 10 hours of growth, the final number of cells is 10 to the power 5. So NT indicates or refers to the final count or number of cells, which is equal to 10 to the power 5. Also, the time of growth is given, the time of growth, which is 10 hours, right? So in this question, we have to calculate the doubling time. Okay. So what is the formula of doubling time? We will see it. The doubling time is equal to total time of growth upon number of generations of, obviously, of the microorganism. So it is indicated as small n, right? In the question, the total time of growth is given, but the number of generation is not given. So we have to find out the number of generations, right? To find out the number of generations, the formula is nt is equal to n naught into 2 to the power n. So we will simplify the equation. We will multiply log on both the sides. So the equation will become like this. Okay. After that, we will move log n naught to the left side. So it will become log n naught minus, sorry, nt minus log n naught, which is equal to n into, and the log 2 value is 0.3010. Okay. So that, so we can make the equation as log n is equal to log n naught, sorry, nt minus log n naught upon 3010. So this is the equation we will use to find out the number of generations. Okay. So we will put the values in the equation. Log nt value is 10 to the power 5, log n naught value is 10 to the power 2, and it is 0.3010. Log 10 to the power 5 value is 5, log 10 to the power 2 value is 2, and it point upon 0.3010. So it is 3 upon 0.3010. So it will cancel out and it will come 10. So the number of generation is 10. So we can easily find the doubling time now. So it is the total time of growth upon n. So the total time is given 10 hours and n is equal to 10. So 10 cancel out and the answer will be 1 hour. Okay. Next question. A microorganism is grown in a batch culture using glucose as a carbon source. The apparent growth yield is zero point 0.5 gram biomass upon gram substrate. So the apparent growth yield is 0.5. Okay, this is an important point. The initial concentration of biomass and substrate are 2 gram per liter and 200 gram per liter. So initial concentration of biomass, how much? It is 2 gram per liter, and the initial substrate, it is given 200 gram per liter. Okay. Assuming that there is no endogenous metabolism, the maximum biomass concentration that can be achieved is. So the maximum biomass concentration we have to find out. Okay. So this question can easily be solved by using logic. Okay. You see, apparent growth yield. What does this mean? This means by using 1 gram of substrate, we can produce zero point 0.5 gram of biomass, right? Okay. So in the question, it is given that the substrate is equal to 200 grams, right? So how much biomass will be produced with the help of 200 gram substrate? Obviously, it will be 100 gram biomass. Okay. So is this the maximum biomass concentration? The answer is no. Why it is not? Because the initial concentration of biomass is also given, because this value 2 gram per liter was initially present. So this was the initial biomass present, and by utilizing 200 gram substrate, a fresh 100 gram of biomass is produced. So the combined answer will be, we will add it up, and the maximum biomass concentration will come out as 102 gram per liter. So this will be the answer. I hope it is clear. Now we will move to the next question. The specific growth rate of a yeast having a doubling time of 0.693 hours is. So in the question, doubling time is given, which is equal to 0.693, and the question is asking specific growth rate, which is mu. Okay, so there is a formula to find out doubling time, which is equal to ln2 natural log 2 upon mu. Okay, this is also a formula to find out doubling time. Okay, so in this question, we have to find out the specific growth rate, that is mu. So we can interchange these values, right? So to find out specific growth rate, the formula will become natural log 2 upon time of doubling. ln2 value is equal to 0.693, and the doubling time given is also 0.693. So these both will cancel it out, and the answer will come 1 per hour. So the specific growth rate is 1 per hour. I hope it is clear. Now we will move to the next question. The figure below depicts simplified metabolism and transport reaction taking place in the production of B from A in a cell. So this compound B is produced by A, utilizing A in a cell. Okay, B is produced from A. The subscript I refer to the intracellular metabolites. I refer to the intracellular metabolites. Okay, and Rj is the Jth reaction flux, and this is its unit. Okay, it's given as gram per gram dry mass, something like that. Under pseudo steady state condition, the following reaction flux are available. So the R1 value is 4, R3 is 1, and R6 is 1. In the question, it is asking to find out the transport flux of B, which is R4, right? So let me just change the ink color. So the R1 value is given 4. R1 is 4, right? And at this point, A1 point, it is bifurcating into R2 and R3. And in the question, R3 value is given equal to 1. So what will be the R2 value? If R3 is 1, R2 will be the 2 minus 1, sorry, 4 minus 1, right? That is left out. The answer will be 3. R2 will be 3, right? Next upon, till Bi it is 3, right? And this at this point, it is again bifurcating into R4 and R6. And R6 value is given 1. So what will be R4? R4 will be 3 minus 1, which will be equal to 2. Correct? So the question is asking this only, the value of R4, which is equal to 2. I hope it is clear. This is the answer. Now we will see the next question. A pilot sterilization was carried out in a vessel containing 100-meter cube medium with an initial spore concentration of 10 to the power 8 spores per ml. In the question, it is given initial spore concentration. How much? It is 10 to the power 8 per ml. Okay. And what is the vessel volume? Volume of vessel will be equal to 10 to the power, sorry, 100 meter cube. We have to convert it into ml. Okay. So you will be knowing that 1 meter cube is equal to 1000 liters. Okay. So it will be equal to 100 into 1000, 10 to the power 5 liters. Correct? And 1 liter consists of 10 to the power 3 mls. Right? So the answer will become 10 to the power 8 ml. So the initial number of cells, yeah, initial number of spores, if we want to calculate it, we can use that. See, in 1 ml, there are 10 to the power 8 spores, and the total ml is 10 to the power 8, right? There are 10 to the power 8 ml of volume, and in each volume, there are 10 to the power 8 spores. So the initial number of spores will be 10 to the power 16 spores per ml. Sorry, 10 to the power 16 spores in the whole vessel. In the whole vessel. Okay. In the entire vessel. Now, the accepted level of contamination after sterilization is 1 spore in the entire vessel. Okay. So, after sterilization, the accepted level is only 1 spore in the entire vessel. So, the final spore count is 1. Okay. The specific death rate constant for the spore is 2 per minute. Death rate constant is Kd, right? So it is given as 2 per minute at 121 degrees Celsius. Assuming no death takes place during the heating and cooling cycles, the holding time at 121 degrees Celsius is. It is asking holding time. Holding time. Okay. So the formula to calculate this is Nt is equal to N naught into e to the power minus kd t. So this t, it is the holding time, right? So we will simplify the equation. We will move N naught on the left side. So it will become like this, e to the power minus kd t, minus kd t. Okay. Now we will apply natural log on both the sides. The equation will become like this. Now we have to eliminate this minus sign. So we will multiply minus on both the sides. On multiplying both the sides, this n naught will go up and nt will come down. Okay. So the equation will modify like this. So from this equation, if you want to calculate t, we can calculate t by moving kd on the left side. And if we want to calculate kd, we will move t on the left side. So in this question, we have to find out the holding time, right? So the equation will become 1 upon kd ln n naught upon, sorry, n naught upon nt, right? Correct. So this is the equation to find out holding time. Okay, now we will apply the values to it. So t is equal to 1 upon, what is the value of kd? Kd value is given as 2 into ln n naught. What is n naught? 10 to the power 16 upon 1. Okay, which will be equal to 1 upon 2 ln 10 to the power 16. Okay, so if you will calculate, the value of ln 10 to the power 16 will come as 36.84. Okay, now we will cut with uh, 2, right? We will cancel it out. So the value will come as 18.42. Now the question is asking the answer should be rounded off to the nearest integer. So the nearest integer to this value is 18. So the answer will be 18. I hope it is clear. So I hope you liked this video. If you liked it, please like the video, share it with your friends, and please do subscribe the channel. Thank you.